Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 16 to 20 of the Geometry January 2015 Regents examination. All right, let's take a look at problem number 16. It reads, triangle ABC graphed on the set of axes below, this triangle right here. What are the coordinates of the point of intersection of the medians of triangle ABC? Now, a few things you want to note for this problem. First of all, the median or a median is a segment that joins the vertex to the midpoint of the opposite side. So if I draw a segment from this vertex to the midpoint of this opposite side, that will be a median. A triangle has three medians. Okay. Secondly, the point of intersection of the medians is known as the centroid. Okay, and this problem is asking for the coordinates of the point of intersection of the medians. So in other words, it's asking for the coordinates of the centroid. All right, these are the steps we're going to follow to solve this problem. First of all, we'll sketch the medians to give ourselves a visual. Then we're going to use the centroid median theorem of 2-to-1 division ratio to determine where the centroid is located on a median. Okay, so the setup from step 2, we're going to solve it to determine the split of the median and then find the coordinate of the centroid from there. All right. In this problem, we need just one median to solve the problem. So there are three medians that we can draw, but the question is which median enables us to accurately count how long each section is. If you notice, if we draw the median through vertex A, we're going to have a perfectly horizontal line. Okay, and that will be the best median we can use to determine what the coordinates of our centroid is. So let's go ahead and sketch this median right here. That's one of them. So the centroid is located somewhere on this line. The question is, where on this segment is the centroid located? All right, let's call this point right here the point where this median bisects segment BC. Segment BC is 6 units long. So if we bisect it, these two sides are congruent. You can see 1, 2, 3, 1, 2, 3. Okay, so that's a bisector right there. That's a condition, and it must intersect the vertex that's opposite the side that it bisects. Now, the centroid is somewhere here. How can we find it? Let's call this point point F. Okay. Now, what we're going to do is use the um, centroid median theorem to divvy up this median. Okay. So let's go ahead and write down what the centroid median theorem is. Centroid median theorem. What it basically says is that the centroid basically divides the median into a ratio of 2-to-1. Okay, so let's write that down. The centroid divides AF, the median, into a ratio of 2-to-1. This is one way of looking at the centroid median theorem. But there's an easier way of looking at it. If it divides a segment into the ratio 2-to-1, that basically means that the longer side is 2/3 of the entire length. Okay, so let's call G the centroid. So let G be the centroid. We don't know where it is at right yet. Okay, let G be the centroid. So according to the centroid median theorem, 2/3 of the entire median length, the median is AF, 2/3 of AF is going to be the length from A to the centroid G. Okay, I like to call the median, the sections of the median divided by the centroid, I like to call them the vertex side and the base side. The longer side is normally the vertex side, and the base side is shorter. What do I mean by that? The vertex side AG is 2/3 of the entire length. Guess what? The base side is 1/3 of the entire length. So AF, 1/3 of the entire median, will give us the centroid to the base F. All right. So we have a situation right here. AF is 6 units long. 2/3 of this from A would take us to the centroid. So what is 2/3 of AF? What's 2/3 of the entire length? Let's go ahead and calculate it. AF is equal to 6 units. That's given, right? So AG, the length from the vertex A to the centroid G, is going to be 2/3 of AF, which is 6. And then if you carry out the calculation, 2 times 3 is 12 over 3, which is 4. Okay, so AG is 4. So 1, 2, 3, 4. 1, 2, 3, 4. Bam. So what is this? What is this point called? This is the centroid G. Okay? And we have 2 units left here. Let's test our theorem, the second side, to see if this result is true. Our theorem tells us that 1/3 of the entire median length will be the shorter side or the base side of the median, right? Let's see if that's the case. What is 1/3 of the entire length of our median? 1/3 of 6. What is 1/3 of 6? That should be GF. 1/3 of 6 is what? It's 2. So this implies that GF is equal to 2. Is GF 2? Absolutely, 1, 2. So it splits it into the ratio 2 to 1. So this side here is 4, and this is 2. Do you see the 2 to 1 ratio here? If you double 2, if you take half of 4, you get 2, right? So 2 to 1, you see that ratio there. Excellent. So this is the centroid just using one median. Now, what's the coordinate of this point? -1, comma 2. -1, 2. Our answer is option number 1. All right. Let me go ahead and show you the remaining 2 medians. You don't really need to use this, but I just want to show it to you. It looks very nice. So we go from this vertex through that centroid, boom, right there. And then the third median goes through there, boom. So this point right here, the point of concurrency of the 3 medians, is known as the centroid. All right, so don't forget that. That has some great applications in physics and center of gravity calculations. All right, let's take a look at problem number 17. It reads, given the statement, if a number has exactly 2 factors, it is a prime number, what is the contrapositive of this statement? Now, one thing you want to note about problems like this is a logic problem, is that the converse of the inverse of a conditional statement is the contrapositive. Basically, you're taking the reversal of the negation of the hypothesis and the conclusion. All right, so the steps we're going to follow to solve this problem are as follows. Number 1, we're going to identify the hypothesis P and the conclusion Q of our conditional statement. All right, after accomplishing that, we're going to find their negation. Not P implies not Q, which is known as the inverse. And then we'll find the converse of that by switching the order of the hypothesis and the conclusion. Basically, the negation of the conclusion implies the negation of the hypothesis. Okay, so that's what we're going to do. So first things first, let's go ahead and rewrite the statement and determine what our hypothesis P and conclusion Q are. Okay, so the original statement is known as the conditional statement. The conditional statement is of the form P, the hypothesis, implies Q, the conclusion. Okay, let me color code it so that we can keep everything organized and delineated. So P is our wrong color. P is our hypothesis, and Q is our conclusion. All right, so let's see if we can identify the hypothesis and conclusion in the statement. Okay, so I'm going to write it in such a way that it's easy for you to see. So if a number has exactly two factors, if a number has exactly two factors, okay, it is what? A prime number. Okay, it is a prime number. All right, now can you see the hypothesis and the conclusion of this statement? The hypothesis is this first portion right here. That's our hypothesis. A number has exactly two factors. Okay, and this right here is, it is a prime number. Think about it. A number has two factors, namely itself and 1. So it's a prime number. Yeah. Okay, so this is our hypothesis here. Hypothesis, which is P, and this is our conclusion, which is Q. Okay. Now what are we going to do? We're going to negate both of them and switch their order. Okay. So how do you negate a statement? Well, we just basically change is to is not, has to does not have. Okay, that's how you find a negation of a statement. Okay, so let's start with the hypothesis. What is the negation of P? A number has exactly two factors. See that has there? We're going to change it. A number, a number does not have two factors. Does not have. Have and does not have are opposites, right? So if you negate have, like you have money, the negation is you don't have money. All right. So a number does not have exactly two factors. Exactly two factors. So that's the negation of the hypothesis. Now, can you negate the conclusion? What is the negation of the conclusion? What is not Q? Is a prime number? What is if something is not a prime, if something is not a prime number, then it's not a prime number. It's kind of redundant, but the negation of something is a prime number is that it is not a prime number. So not a prime number. All right, not a prime number. Okay, so this one is a prime, this is not a prime. So that's the negation. All right, so just put not uh, in the statement in such a way that it makes sense in English. All right. So let's go ahead and do a real quick review. Remember, conditional. Conditional is what? Conditional is P implies Q. That's the original statement. Okay. What is the inverse? The inverse is when you negate both of them. So not P implies not Q. That is what we just did. We just found the negation of the two. If we had this implies that if a number does not have exactly two factors, it is not a prime number. That's the inverse. Now what is the converse? The converse is when you switch the order. Q implies P. All right? Switching the order. So if we combine these together, these two together, it gives us the contrapositive. So the contrapositive means, contrapositive is not Q implies not P. So we just form a, if we just form a statement using this as the hypothesis and that as a conclusion, we are done. All right? So let's go ahead and write it. So not Q if a number is not prime, if a number, well, let's color code it so we can keep track of how things are switching around in our statement. So if a number is not prime, if a number is not a prime number, okay, comma, then it does not have exactly two factors. Okay, then let's write down the negation of the hypothesis. It does not have have exactly two factors. Exactly two factors. So this is the contrapositive. Okay, so if you look at the options that we have, um, our answer is option number 2. If a number is not a prime number, then it does not have exactly two factors. Option 2. All right, so there goes a brief review on logic statements. All right, let's take a look at problem number 18. It says, which graph represents a circle whose equation is x minus 2 square plus y plus 4 square equals 4? All right, one thing you want to note when solving problems involving circles is that when you are trying to extract h and k from the equation of a circle in center radius form, you always invert the sign of the number for the h and the k, okay? Keep that in mind. The steps we're going to use to solve this problem are as follows. We're going to write down uh, the center radius equation of a circle to guide our variable selection process. And then we're going to use that to determine the center and radius of this circle, the circle with this equation, and then compare it to our options here to see which one matches, okay? So while we're at it, why don't we just find the center and radius of all these circles right here? Circle for option number 1, center is -2, 1, 2, 3, 4. Center is -2, 4. And the radius r is 1, 2. Radius is 2. In option number 3, the center is 2, 1, 2, 3, 4, -4. And the radius is 2. Distance from the center to the circumference, okay? Here we have center 1, 2, 2, I'm sorry, -2, comma 1, 2, 3, 4, 2, comma 4. And the radius is 1, 2, 3, 4. The radius is 4. And in this one, the center is 1, 2. Nope. 1, 2, yes. 1, 2, 3, 4, -4. And then the radius is 1, 2, 3, 4. So the center is 2, comma -4, and the radius is 4. I'm doing it the long way because I want you all to go through the process of determining the center and radius accurately. All right, so now let's find write down the equation of the circle in center radius form. The equation is x minus h quantity square plus y minus k quantity square equals r square. All right. So the equation we have is x minus 2 quantity square plus y plus 4 quantity square equals 4. Now, now we're done with step 1. Step 2 is to determine what the center and radius are. Okay. So from this, what do we have? We have the center is HK, okay? So this is where you want to be really careful. You see the x coordinate, see that -2, you take the opposite of that. That gives you, you get 2. No, I think I'm doing this backwards. Let's figure out what h and k are first, and then we can figure out the center. Sorry about that. Okay, so let's find h and k. So h is the x coordinate of our radius. So h is equal to uh, 2. Okay? H is equal to 2. You basically take the opposite of -2. And then k is the negative of +4, -4. Yes. And then we know that r squared is equal to 4. So to get r, we just root both sides. That tells us that r is 4. Okay? Now we know what the center is. The center, HK, kind of getting ahead of myself, is 2, comma -4. And the radius, r, is 4. Radius is not 4. Radius is 2. If you take the square root of 4, you get 2. Sorry about that. Okay, so the radius is 2. Radius is the square root of 4, which is 2, and the radius is 2. So now what we're going to do is we're going to take a look at our circle and see which one has a center of 2, -4, and a radius of 2. 2, -4, and a radius of 2. Answer is option number 3. Okay? All right, so let's move on. All right, let's take a look at problem 19. It says, if two sides of a triangle have lengths 4 and 10, the third side could be, so we have 4 options here, only one actually works. So one thing you want to note is that to satisfy something called a triangle inequality, something that now enables a triangle to be constructed, the sum of any two sides must be longer than the third side. Okay? So the steps we're going to use to solve this problem is 1, we're going to write down the triangle inequality that ensures that you can construct a triangle given 3 sides. We're going to label A, B, and see which option satisfies all 3 parts. Okay? All right, so let's go ahead and write down what the triangle inequality is first. So the triangle inequality, triangle inequality, triangle inequality is as follows. A triangle, with sides A, B, and C must satisfy the following. Okay, must satisfy the following conditions. This is a requirement. Conditions. All right. So condition number 1, it has to satisfy all 3. Okay, no exceptions here. Condition number 1: A plus B, side A plus side B must be greater than side C. Now, can you determine what the other 2 conditions are? Condition 2, side A plus C has to be bigger than the third side, which is B. And then the third condition is that sides B plus C has to be greater than the third side A. Okay, so the sum of any 2 sides must be longer than the third side. That is what the triangle inequality is. These 3 inequalities have to be satisfied in order to create a triangle. Okay, if it's not satisfied, then you have a situation where the triangle kind of collapses. All right, now we'll just advance to step 2, where we assign letters to the side lengths of our triangle. So let's call the 2 sides that we know A and B, okay? So let A be equal to 4 and B is the other length, 10. So that's A and B. What is C? We don't know what C is. C is one of the four options that has to ensure that the triangle satisfies the triangle inequality theorem. Okay, sum of two legs must be bigger than the length of the third side. So what we'll do in this problem, we're just going to work through the different options that we have. We'll test them to see which one passes all three uh, inequalities. All right, so let's start with option number one. So for option one, the candidate for C is 8. So will this work? Let's try statement 1. Statement 1 is A plus B has to be greater than C. Okay, so A is 4 plus 10. The question is it greater than our C candidate 8? Is it? 4 plus 10 is 14. Is 14 greater than 8? The answer is yes. So it passes the first test. So we advance to test number 2. Test number 2 requires the sum of A plus C to be bigger than B. A is 4, C is 8. That's our candidate. The question is 4 plus 8 bigger than the third side 10? Is A plus C greater than 10? 4 plus 8 is 12. Is 12 greater than 10? It certainly is. Yay, it passes test 2. Next step is test number 3. The question here is B plus C greater than A? Is 10 plus our C candidate of 8, is it greater than 4? That's the question. 10 plus 8 is 18. Is 18 greater than 4? Is it? It certainly is. So this option 1 passes all three tests. Okay, so what does that tell us? It tells us that C is equal to 8. That is the third side that will enable us to create a triangle. Okay, so let's write down a quick remark. Since setting C equals to 8 satisfies all three conditions, three conditions of the triangle inequality theorem. What does that tell us? Option 1, C equals 8 is the answer. Okay, so that's that. All right, number 20, it says the lines represented by the equations 4x plus 6y equals 6 and y equals 2 over 3x minus 1 are what? What are they? Are they parallel, the same line, perpendicular, or intersecting but not perpendicular? Now, one thing you want to note is that the best and efficient way to compare two lines is by placing them in the same form where they are reduced completely. Okay? So these are the steps we're going to take. First of all, we're going to place the two lines in the slope-intercept form. I prefer that form because it's easier to determine the slopes, okay, and y-intercepts. When we're done, we're going to compare the y-intercepts, B1 and B2 of the two lines and their slopes. And that will help us to see if they're parallel, same line, perpendicular, intersecting but not perpendicular. Okay, let's do a real quick review here. When do you know that two lines are parallel? Line 1 is parallel to line 2 if M1, the slope of the first line, is equal to the slope of the second line, right? Two lines are the same if the slopes are the same, M1 is equal to M2, and the y-intercept, if we're looking at uh, slope-intercept form, B1 is equal to B2. They're basically identical. That's what it means for two lines to be the same line, all right? They're perpendicular if M2 is the negative reciprocal or the inverse of M1. Or if you multiply both of them and get negative 1, then they're perpendicular. Intersecting but not perpendicular basically means that it does not satisfy condition 1, But the B1, the B's are, um, so it basically does not satisfy condition 1, and the B's are distinct, okay? Oh, sorry, I meant to say it does not satisfy condition 1, and it does not satisfy condition 3 also, okay? So if two lines are intersecting but not perpendicular, um, intersecting but not perpendicular, we're going to have M2 is not equal to negative 1 over M1. Okay, that means that they're not perpendicular. Okay, that guarantees that they're not perpendicular. Now, if we want to interpret intersecting as intersecting at a point, if two lines are not perpendicular, and you want to ensure that they intersect, all you have to ensure is that the slopes are different. Okay, if two lines have different slopes, they must intersect somewhere. The question is your intersection going to be at 90 degrees or not? So in this case, we do not want the intersection to be 90 degrees. So we've already said M1, M2 cannot be negative 1 over M1. And we don't want it to be parallel, so M1 cannot be equal to M2. Okay? Now, what we're going to do is put both equations in the slope-intercept form, and then we're going to compare them. Okay, when the slope-intercept form is much easier to carry out our comparison. Okay, so let's take a look at equation 1. Equation 1 is almost in standard form. It can be reduced a little bit more though. So equation 1, we have 4x plus 6y equals 6. If you place it in slope-intercept form, that basically means you want to put it in y equals mx plus b form. You want to get y by itself. So accomplish that, we can subtract 4x from both sides. That yields 6y equals negative 4x plus 6. And then we can divide both sides of the equation by 6 to get y isolated. Okay, so divide by 6, divide by 6, divide by 6. All right, so what is our slope-intercept form? I'm going to call this y1, line number 1, is equal to, if you divide this by 2 top and bottom, the GCF, you have negative 2 over 3x plus 6 over 6, which is 1. So this tells me that slope of line 1, m1, is negative 2/3, and the y-intercept of line 1, b1, is 1. Okay, excellent. Now let's move on to equation 2 and see what we can grasp from that equation. Equation 2, we have y equals 2/3 x minus 1. Oh, it's already in slope-intercept form. So we can easily extract the values of m2 and b2 from this. Okay, so let's see what we have here. So m2 is the coefficient of the x. Remember the number in front of x, that's m. So m2 is 2/3, and b2 is negative 1. All right. Okay, option number 1. Are they parallel? In order for them to be parallel, M1 and M2 must be the same. Are they the same? Nope. So since M1 is not equal to M2, they are not parallel. They are not parallel. So can option 1 be the answer? No, we eliminate option 1, cross that out. Now how about the second option that has to do with them being identical? Are the M's and B's the same? Nope. M's are different and B's are different. So, and then just looking at the two lines alone, they're not identical. So that's even sufficient to conclude that they're not the same line, because we put both of them in slope-intercept form and they look different. Okay, so since y1 is not equal to y2, they're not the same, that means that they are not the same line. Okay, they are not the same line. So what does that tell us about option 2? Option 2 is not the answer. All right, how about perpendicularity? Remember, the condition for perpendicularity is that M2 has to be the negative reciprocal of M1. All right. So what is the negative reciprocal of M1? The negative reciprocal of M1 is positive 3 over 2. Okay. So let's write that down. Since M2 is not equal to negative 1 over M1, negative 1 over M1, if you want to do the calculations, is 3 over 2. Since M2 is not equal to 3 over 2, what does that mean? That automatically means that they are not perpendicular. They are not perpendicular. All right, so what does that tell us about option 3 concerning perpendicularity? That's not the answer. Okay, by method of elimination, our answer should be option number 4. And we clearly see that that's the answer, right? Because first of all, they're not parallel since the slopes are different. That means they're intersecting. They're not the same, so we don't have infinite intersection. We just have one intersection at a point. And they're not intersecting at 90 degrees because M2 is not the negative reciprocal of M1. All right, so since M1 is not equal to M2, that guarantees that they are not parallel. If two lines are not parallel, they must intersect either once or infinite number of times. We know infinity is not an option here because they're not the same. And M2 is not the negative reciprocal of M1. It's not 3 over 2. That guarantees that they are not perpendicular. Is not equal to negative 1 over M1. So since they're intersecting and not perpendicular, so they are intersecting because of the first condition, and not perpendicular because of the second condition. So what does that tell us about option 4? That is our answer. Yay, we finally got the right answer. Okay, so that's that. Thanks so much for taking the time to watch this presentation. Really appreciate it. We'd like your feedback. If you found this tutorial beneficial to you, do give us a thumbs up so that we can know how to improve on it. And if you have any questions or comments, just include it in the comment section below, and we'll be glad to address it as soon as possible. Do not forget to subscribe to our channel for updates to other great tutorials such as this. More clips can be found on mathgotserved.com under test prep. Thanks again for watching and have a wonderful day.